two numbers a and b are called coprimes or relative primes if GCD of these numbers is 1. Some examples are 12 and 35 are coprimes, even 21 and 64 are coprimes. Now let's learn the method to find out the number of coprimes less than n. For this, we'll be following the Euler's method, which says that the number has to be prime factorized. So n could be written as p to the power of a, q to the power of b, and maybe some r to the power of c. And the Euler's number for an integer n is the integer multiplied by 1 minus 1 by first prime factor, then 1 minus 1 by second prime factor, then third, and so on. To understand this, let's take an example. Uh, let's take the number as some 20. So as per the technique, we need to go for the prime factorization. So 20 can be written as 2 square into 5 power 1. Then the Euler's number for 20 will be 20 multiplied by 1 minus 1 by 2 into 1 minus 1 by 5. This becomes 8. And to check whether this is right or wrong, we can also go for the manual verification. And when we try to list out all the coprimes less than 20, and they are 1, 3, 7, 9, 11, 13, 17, 19, exactly 8. Here is a question asked in GATE 2005. Let n is equal to p square q, where p, q are distinct prime numbers. How many m satisfy 1 less than or equal to m less than or equal to n, and GCD of m and n is 1? And there are some options. When you analyze the question, here they're trying to say that there are two numbers whose GCD is 1. Nothing but these two are coprimes. And here they are saying that find out that m which is less than n. This is just counting the number of coprimes which are less than n. Here we'll be using the Euler's technique. N is p square q power 1. P and q are prime numbers, so this is the prime factorization. Now when we find the Euler's number for n, which is equal to n into 1 minus 1 by p into 1 minus 1 by q, but n is p square q. On simplification, we get p into p minus 1 into q minus 1, nothing but option D.